This video, I'm just going to reiterate all the stuff we saw at the end of class on Thursday, our introduction to systems of linear equations. All of these things are things I could put on the quiz for Tuesday. So first thing to know about systems of linear equations is what we're talking about when we look for a solution. So a system of linear equations is something that is going to look like this. It's basically a set of two or more linear equations. And just like a solution to a regular equation, we need to find values that make our equation true. And in this case, our equations true. So there are going to be two different pieces to this solution, the x and a y. And so our solutions are generally going to look like this, an ordered pair. There are some exceptions to that, which we will see in a later video. So your solution's looking like that. You have three different ways to solve these, as we discussed in class. Method 1 is to graph the lines. Because we did have some people say, well, we could guess and check, and if the question's easy enough, maybe we can get there, but there's an infinite number of solutions to this line and an infinite number of solutions to that line. So a better bet would just be to go ahead and graph both of these. And these are not terribly difficult equations to graph, so we'll go ahead and start with that. The difficult part is going to be the fact that I should have just inserted a picture of a graph so that I didn't have to do all of this work. So first I'm going to go ahead and graph in green y is equal to 2x. So remember, there's an invisible plus 0 here. And if I want to use just the slope and intercept to graph this, the intercept is 0, so we're going to cross at the origin. And then my slope of 2 tells me that I'm going to do 2 over 1, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. So, oh, that's sketchy, but there we go. There's my graph for the first line. I'll do the second line here in blue. Right? So all of the points on that first line are things that make that equation true. And now I'm going to figure out all the things that make the second equation true. So again, I'm just going to use slope and intercept to graph this instead of making a table, but a table is legit. I'm going to start at 10. And this one has a slope of -3. So that means we're going to go down 3, right 1. So down 3, right 1, down 3, right 1. Ooh! That's the magic right there. If we're lucky, that's what happens, is that a point that I found for both of these is exactly the same. This appears to be 2, 4. And if I wanted to check my work, I would just plug that into both the lines. So y is equal to 2x. That's 4 is equal to 2 times 2. That's correct. Y is equal to -3x plus 10. Well, that would be 4 is equal to -3 times 2 plus 10. -6 plus 10. Boom. So, perfect. This is my solution. I am done. So that's one method, to go ahead and graph these. Method 2. Let's go ahead and do the exact same two lines. So y is equal to 2x and y is equal to -3x plus 10. The second method we learned in class was substitution. So substitution is nice, especially when we have one equation solved for a variable, which we do have here. We can look, either equation is actually fitting this, but at least one needs to be. So we have y is equal to 2x. This is nice because in the other equation, we also have a y. And if we know y is 2x, we can just plug that on in. We can substitute that in to the second equation. So instead of y, I'm going to write 2x, and then I'm just going to write the entire equation as it was. So I'm going to substitute the first equation into the second equation, right? And the reason why this is awesome is because now, woohoo, we have one equation and it only has one variable. which we know how to solve. We would go ahead and say, all right, let's add 3x so we can get the x variables on the same side. We'll combine up our like terms to get 5x is equal to 10, and then we'll divide by that 5 to get x alone, because that 5x means 5 times x, and the opposite of multiplication is division. Now, the one piece you have to remember with substitution is that you're not done. The whole goal is to get an ordered pair, which you'll never forget if you're doing the graphing method. So we got to do one more step. So step 1, if you wanted to have steps here, would be solve an equation for a variable. In this case, we didn't have to do step 1. It was already done. Step 2 would be sub into the other equation for that variable. Which is what we did here. Step 2 was this piece, right? When we subbed in that 2x. And the goal of step 2 and step 1 is this. This is our goal. One equation with one variable. Then you could have a step 3 if you really wanted steps here, which is to solve for the remaining variable. And then your step 4 is plug back in to the equation from step 1 to get other variable. And the reason why we might want to use the equation from 1, remember this equation that we had in part 1, is that it's already solved for the variable we're missing. So I'll go ahead and bring that down. We'll do step 4, because all of this stuff was step 3, right? We'll do step 4 by taking our y is equal to 2x and saying, oh, well, we already know x is 2, so that just means that y is equal to 2 times 2, which is 4. And then if you wanted to step 5, what you should do last is check, right? But we already checked this because we did this in another method already. So this looks good. And then make sure that you do write your final answer as an ordered pair. Boom. Okay. So there's only one more method left to solve these things. That's method 3. And that method is elimination. And for elimination, I'm going to go ahead and get us a different example than the one we did. We can still tackle the one we had before, but we might as well just do a different one. All right, so I got us a new example here. And just to note, elimination is going to be nice when our equations are in standard form. This is a question we could solve using substitution if we wanted to, the method we just covered. If we were going to use substitution, I'm just going to kind of quickly run through this. You would need to decide which of these 4 variables is the easiest to solve for. Easiest to solve for is always going to be our, sorry, I'm trying to figure out my undo button and I can't find it. It's missing, so I'm giving up. Is always going to be, yes, I found it, the variable with a coefficient of 1. In this case, a coefficient of -1. The reason is if we try to solve for this y, because that's what we need, right? That's step 1 of substitution, is we're going to go ahead and say, let's subtract 4x from both sides. Negative y is equal to negative 4x minus 4. And then we'll divide everything through by that -1 that we know that negative sign is all about. Y is equal to 4x plus 4. Now we could take this and plug it in there, right? Bloop. But if we'd used any other value here, any other variable and tried to solve, we're going to end up with some fractions. So I just wanted to point that out, that you will end up with fractions unless you choose really smart when you're doing your substitution. So that's why substitution could get you in trouble here. And I can see a bunch of places where we might forget that negative sign or have some mistakes. So instead, let's do this one with elimination. So remember, with elimination, our goal, oops, it's always nice to have a goal in mind. Goal is opposite coefficients on a variable. The reason is that eventually we're going to add all of this stuff together, and our goal is that we're not going to have two variables, right? Just like when we did substitution, we want one equation with one variable. That's the goal. So if we add our two equations together and we get two variables, we haven't helped ourselves at all. So the goal is to get opposite coefficients. So for this one, doesn't really matter. We could try to eliminate the x's or eliminate the y's. I think the y's are a little bit easier to eliminate here because what we're essentially doing is trying to figure out our least common multiple, which is kind of like finding a common denominator. And between 4 and 3, we'd have to go with 12. So we'd have to multiply both equations, which is a place to make mistakes. But between a 1 and 2, I only need to multiply one of these equations. So I'm going to go ahead and multiply the top equation through by -2 on both sides, right? So this is now going to be negative 8x. -2 times a positive times a -1 is a positive 2y, and a -2 times a -4 is a positive 8. And then I'll just rewrite the other equation right under it because I did not need to change that. And we can already see we've got our opposite coefficients here on our y's. So now if we go to add this together, which by the way is allowed because I'm essentially saying this and this are the same thing, and I'm adding them to this and this, which are the same thing. So should end up being the same on both sides still. We're keeping the sides of our balance, our scale balanced. So now we have a -5x is equal to 20. And now we're to that point, right? We've got our one equation, one unknown, which I can just go ahead and solve very simply. Since x is being multiplied by a -5, I'll divide by a -5 and end up with x is equal to -4. So if you wanted steps again, step 1 would be put the equations in standard form. Which is usually when I would use this anyways, and so we already had that done. We didn't have to do step 1. Step 2 is to multiply one or both. We'll go ahead and say one or both equations by a number so that we get opposite coefficients on a variable. And then 3, add the equations together. And if they're in standard form, everything should be lined up and there should be no mistakes at all. We still have one more step, right? Just like in the last problem, all we have right now is x. We also need y. So we go to say step 4. Oh goodness, I wanted back to the original. Step 4, plug. I guess step 4 is actually solve for the remaining variable because we had to do that one piece. It's always going to just be divided by that coefficient. So step 4 happened there. And then step 5, plug into either equation to find other variable. So it doesn't matter which equation we plug into. We're going to plug into whichever one we think is easiest. So looking up here, I like the one that has a 1 as a coefficient, a -1, because I won't have to do any division at the end, except for flipping signs. So I'm going to use that. So we have 4x minus y is equal to -4. We know, I'm going to keep using these giant pens, we know x was -4. Keep going. Go ahead and deal with this first. We got -16 minus y is equal to -4. We'll add 16 to both sides to get rid of that. And now we have -y is equal to, is that a +12? Ooh, I want my big pens. And our last step, we got to divide by that -1 coefficient. So we end up with y is equal to -12. So right now our answer looks like it is -4, -12. And since we didn't do other work on this one, I'm going to do step 6, which is to check our work. So I'm not going to check it in the equation we just used, because unless I made an error there, chances are it's going to work out fine. I'm going to check it in the other equation. So our other equation, this was 3x minus 2y is equal to 12. So we'll go ahead and plug in 3, so -4 minus 2 times a -12 is equal to 12. Just go ahead and evaluate these. 3 times a -4, -12. Negative times a negative is a positive. And sure enough, that does equal 12. So our answer is correct. We can box it up and be done. So that's it. That's all I'm going to expect you guys to know on the quiz, is just how to do those 2 methods, or those 3 methods, on some very simple questions.